In today's problem, we'll figure out the structure for this NMR spectra. And the addition here is we are dealing with a benzene here. So how do we know? First, we always start by calculating the degrees of unsaturation. In this case, it's 9. It's huge. And the fact that there is a multiplet at around 7 is always indicative of a benzylic ring of an aromatic. So one aromatic ring accounts for 4 degrees of unsaturation, okay? So then, given that we have a multiplet, we don't know how many peaks there are, it could be possible that there are actually 2 of these benzene rings, okay? So that will put us at 8 degrees of unsaturation. And this is because there are 10 hydrogens here, so there are 10 hydrogens due to benzene rings, so that must mean there are 2 benzene rings. So then there's 1 more degrees of unsaturation, and the prompt tells us that there's actually a carbonyl. But if it didn't tell us that, you could still figure it out because there is an O. So you would think, is this an carbonyl? Is this an ether? Is this an alcohol? But because we need something with an alkene, this would be our carbonyl. So first we identify the DU and what functional groups they could be due to, and then double check if it is due to these functional groups by comparing it with our spectra. Luckily in this problem they gave us the integration values, thank goodness. So let's see how we can solve this. So we already know that this is due to our benzene. I like to color code which signals are due to which functional groups. And a carbonyl would actually be at 2.2. Okay, so then there's another mysterious thing at 5 here, which I can check what it is. Okay, that is a mystery. We'll get to that. Okay, so carbonyl. So let's start with drawing our benzene rings. And we're going to put this together, keeping in mind that there is a total of 15 carbons. So now we already have 12 carbons. So obviously we have to connect them. There's no other choice. Okay, by the way, so this is a singlet, right? And this is telling us that it's due to 1 hydrogen. So there is a CH, just a CH, and it's attached to no other hydrogen. So I like to just put a little box here so I know it's going to be a functional group. It's attached to a functional group, okay? And then here this is a CH3 because of integration value of 3, and it's also attached to a functional group because it's a singlet. So that kind of gives us a clue what that functional group could be. Could be the carbonyl, right? So let's draw our carbonyl. And then this is a CH. Okay, but then CH, it must be attached to 2 other things. And you can see here that we have a C and there are 2 other things attached to it. So what we could say is we could have, let's put it together. We could have 2 benzene rings. Okay, and then we have our CH. Okay, our CH, this is one of the signals. And then the CH is attached to the carbonyl, which is attached to a methyl. And then we always work backwards to check if our supposition is correct. How many distinct hydrogen regions are there? There is 1, there's 2, and then there are 3, okay? Because this is symmetrical, so all of these benzene rings account for 1 signal, so there are 3 signals, good. And then we count how many carbons we have. We need 15 carbons and 14 hydrogens, which count it works out great. And that is how you solve this problem.